Today we start a solution chapter in class 12th in the subject of chemistry. Now what the solution is? In our everyday life, we rarely come across with the pure substances. Most of these are the homogeneous mixture of two or more pure substances. Now the solution is a homogeneous mixture of two or more chemically non-reacting substances whose composition can be varied within certain limits. If your solution is made up of two components, one solute and other solvent, then the solution is known as the binary solution. Solvent is that component of the solution which is present in the larger amount by mass, and the other component which is present in minor amount is known as the solute. If the solution having water as a solvent, then we call them as aqueous solution. While if the solvent is not water, then we call them as non-aqueous solutions. Now both the solute and the solvent, they are able to constitute the same phase. Only then it is known as homogeneous solution. How do we classify the solution? The classification of the solution depends upon the number of the components which are present in it. If your solution contains two components, that is solute and solvent, then we call it as binary solution. If your solution contains three components, then it is known as the tertiary solution. And if your solution contains four components, then we call as quaternary solution. Remember one thing, only one solvent is present in the solution, while the rest of the components are treated as the solute. If n components are present in the solution, then the number of the solute components are regarded as n minus 1. The type of solutions. Now, the solution having solvent present in the solid state, then we call them as solid solution. If your solvent is present in the liquid state, then it is known as the liquid solution. And if your solvent is present in the gaseous state, then it is known as the gaseous solution. This means that the solvent always having same phase as that of the phase of the solution. But the solute may or may not be present in the same phase as that of the solution have. Now, in the solid solutions, if we are taking solvent as solid, solute as solid, then the type of solution is known as solid in solid solution. Example is alloy, brass, German silver, bronze, etc. Now if the solvent is solid and solute is liquid, then the type of solution is liquid in solid solutions. Example, hydrated salts, amalgam of mercury with sodium. Now when the solvent is solid and the solute is gas, the type of solution is gas in solid solution. Example, dissolved gases in minerals or hydrogen in palladium. Now in liquid solutions, where the solvent is present in the liquid state, if your solute is solid and the solvent is liquid, then the type of solution is solid in liquid. Example, salt or a glucose or any type of salt which gets solubilized in water. Liquid in liquid solutions, we are having both liquid, that is solute, and solvent are present in the liquid state. Example, ethanol in water, methanol in water. Now, gas in liquid solutions, aerated drinks and oxygen in water. Gaseous solution. In gaseous solution, the solvent is present in the gaseous state. The first example of solid in gas, that is iodine vapor in air, camphor in nitrogen. Liquid in gas, example humidity in air, chloroform mixed with nitrogen gas. Now gas in gas, example air, a mixture of O2 and N2. How can we express the concentration of the solution? The concentration of the solution or a strength can be determined by the amount of the solute dissolved in per unit amount of the solvent. There are the various methods by which we can determine the concentration of the solution. These are mole fraction, mass percent, volume percent, mass by volume percent, part per million, molality, molarity, and normality. Now the first is mole fraction. Mole fraction means the number of the moles of the solute upon the total number of the moles of all the components which are present in the solution. Mole fraction of a constituent, that is solute and solvent, is the fraction obtained by dividing the number of the moles of that constituents by the total number of the moles of all the constituents present in the solution. It is denoted by X. If we want to determine the mole fraction of the solute, the mole fraction of the solute, that is X2, is equal to number of moles of solute upon number of moles of solute plus number of moles of solvent. The mole fraction of solvent, that is X1, is equal to number of moles of solvent upon number of moles of solvent plus number of moles of solute. Second, mass percent. Mass percent means the number of parts by the mass of solute which is present in number of parts by the mass of solute present in 100 parts by the mass of solution. This means that the mass of the solute in gram present in 100 gram of solution. For example, if we want to prepare a 10% by mass of sodium carbonate solution, this means that 10 gram of sodium carbonate is present in 100 gram of solution. Next, volume percentage method. Volume percentage method means the volume percentage method means the volume of the solute in milliliter present in 100 ml of solution. That is the volume of the solute upon volume of solution into 100. Next, mass by volume percentage method. The mass of the solute in gram present in 100 ml of solution. That is the mass of the solute upon volume of the solution into 100. Part per million. Part per million represents the number of parts by the mass of solute present in 1 million part of the solution. That is, part per million is equal to mass of the solute upon mass of solution into 10 to the power 6. Next, molality. Molality means the number of the moles of the solute present in 1 kg of solvent. Here, the mass of the solvent is taken, mass of solute is taken, therefore molality is temperature independent factor. If we increase the temperature or decrease the temperature, the molality of the solution will not get change. This shows that the molality is the temperature independent factor. Therefore, molality is regarded as best method to determine the concentration of the solution. Now molarity. Molarity means number of moles of solute present in 1 liter of solution. The volume of the solution must be in liter. Here the units of molarity is number of moles per liter of solution. Normality. Normality represents the number of the gram equivalents of the solute present in 1 liter of solution. Normality of the solution is defined as the number of the gram equivalents of the solute dissolved per liter of the given solution. It is denoted by the symbol N. The normality of the solution in case of dilution can be determined by using the formula N1 into V1 is equal to N2 into V2. If V1 ml of the solution of normality N1 are diluted to V2 ml and the normality of the diluted solution is N2, or if V1 ml of the solution of normality N1 reacts exactly with V2 ml of solution of normality N2, then we use this formula N1 into V1 is equal to N2 into V2. This equation N1 into V1 is equal to N2 into V2 is called the normality equation. Similarly, if V1 ml of molarity M1 are diluted to volume V2 ml, then the molarity of the diluted solution is M2. Then we have M1 into V1 is equal to M2 into V2, and this is called the molarity equation.